Okay, in this video we're going to find derivatives using the limit definition of the derivative. And later on in the class we'll work on finding derivatives using differentiation rules. But for now we're going to use the definition. And I'm going to use the same definition over and over again. I'm going to use, I'll just get started right with the first one. We're going to use f prime of x equaling the limit as h approaches 0 of f of x plus h minus f of x all over h. And again, this represents by itself, this represents the slope of a secant line to our with respect to our curve. And then once we take the limit as h approaches 0, meaning that horizontal distance gets smaller and smaller and smaller, approaching 0, we end up getting the slope of the tangent line. So that's really what we're after here. That's what the derivative generates. It generates slopes of tangent lines. So with this first one, we're going to go ahead and continue with our limit notation, of course. And then in blue, I'm going to plug in x plus h into here and here, right? We're evaluating our function to the input squared minus 3 times the input plus 7, right? That is our function. And in this case, in blue, the input is x plus h, like that. Next, we're going to subtract from that the function itself, which in this case in green is 2x squared minus 3x plus 7. All that's divided by h like this. Now, of course, we've got to make sure, very important, that we are subtracting all of green, the entire thing. So we need those parentheses there. And of course, we'll be distributing the negative. The next several steps are all algebra. So the main thing you want to make sure is just be careful not to make algebraic mistakes along the way. I'm all up for skipping steps as long as you do so accurately. So for example, x plus h squared is going to be x squared plus 2xh plus h squared. Some of you may choose to distribute the 2 right off the bat. That's fine. I'm going to make sure I don't make mistakes here, so I'm not going to do that right now. But then distributing all this business, I think we're there. And now I'll distribute the 2. These are a decent amount of writing. The good news is very soon in the next chapter, we'll be able to start finding this derivative very quickly using differentiation rules. But for now, this is what we're doing. So we get some cancellation here, the 2x squared with the negative 2x squared. We have a negative 3x and a positive 3x, a positive 7 and a negative 7. So all those are gone. And now we're left with the limit as h approaches 0 of what? 4xh plus 2h squared minus 3h all over h. We can factor out the h in the numerator before we cancel. We end up with something like this. And of course now h divided by h is 1. And we have the limit as h approaches 0 of 4x plus 2h minus 3 like this. Letting h go to 0, we're going to have 2 times 0 here, right? 4x plus 2 times 0 minus 3 will give us just 4x minus 3. And so this is our derivative function. F prime of x is equal to 4x minus 3. Again, this guy generates slopes of tangent lines to the original function way back here. And we'll see more of that as we proceed. But that's the idea. Main thing is be super careful with your algebra going through this. All right, looking at the next one. Same idea. We're going to take the limit as h approaches 0 of, in this case, it's g of x plus h minus g of x all over h. Again, in blue, we're going to replace our input right there with x plus h. So we're going to have the square root of 3 times the input plus 2, and that's going to be an x plus h there. From that, we're going to subtract, we're going to subtract g of x, which is the square root of 3x plus 2. And then on the bottom, we have h still. All right. Now, we've dealt with limits like this before. The main thing we need to make sure that we do is multiply by the conjugate, right? So hopefully we recognize that what we're going to do here is we're going to multiply top and bottom by the square root of 3x plus h plus 2 plus the square root, whoops, I lost a parenthesis there somewhere, 3x plus 2. And then the same thing on the bottom, the square root of 3 times x plus h plus 2 plus the square root of 3x plus 2. And let's see what that gets us. We have the limit as h approaches 0. We're going to do this multiplication here, which will get rid of the square root for us. So we have 3 times x plus h plus 2. So that's our first multiplication right there, right, between these guys. The next multiplication, we have 2 multiplications coming up. This way out here is going to give us a positive product, and these 2 are going to give us a negative product, and they're going to be identical to each other, but with opposite signs. And so those are going to add up to 0. I'm not going to write them this time. If you feel like you need to write it, go for it. But then the last multiplication, right, this is kind of like FOIL, right? First, outers, inners, last. You're doing all your multiplication. We're multiplying the green square root times the orange square root and back. A positive times a negative is a negative. And then everything comes out of the square root, but we have to remember we're subtracting that 3x plus 2 that comes out of the square root. On the bottom, I'm just going to leave the h, and I'm going to multiply it by the square root of 3 times x plus h plus 2 plus the square root of 3x plus 2. Now you might be sitting there thinking, why isn't he distributing this 3 here and that 3 there? And I'm kind of with you on that. It's a little annoying to keep writing the parentheses. So we could have done that really way back at the beginning over here if you wanted to, but I didn't. So we'll just keep going like this. Let's see. So distributing that 3, we have 3x plus 3h plus 2. Distributing the negative 3x minus 2 all over. We have an h on the bottom. And of course, I'm going to distribute this guy right here. We get 3x plus 3h plus 2 plus the square root of 3x plus 2. Notice, tons of algebra, not really much calculus happening. Equals the limit as h approaches 0. On top there, 3x cancels with negative 3x, 2 with negative 2. You're probably noticing all you have left on top is a 3h. And some of you might be thinking, let's not write this whole next step. Let's go ahead and do our cancellation, but I've already started. So we're just going to keep going. Plus 3h plus 2 plus the square root of 3x plus 2, like that. Now the h's cancel. And as soon as those h's cancel, we're in good shape, right? Because it was the h that was giving us the 0 over 0. So the limit as h approaches 0 of 3 over the square root, let's clean that up a little bit, the square root of 3x plus 3h plus 2 plus the square root of 3x plus 2. All right. Plugging in 0 in for h right there, not for x. I see people do strange things after all this work, and then they put the 0 in for x, but that's not the case. We're plugging it in for that h right there, and that's going to cancel off that term, right? 3 times 0 is 0. So we end up with a 3 on top. We have the square root of 3x plus 2 plus the square root of 3x plus 2, and that will give us a 3 on top. And we're adding two roots with the same expression under the root, right? The same, what we call radicand. And so that's like adding a y plus a y equals 2y. So adding these is 2 square root of 3x plus 2. And there we have it. We just found g prime of x. I didn't write it way back here. Here, come back over here for a moment. I really should have put g prime of x like that. Anyway, g prime of x is equal to 3 over, and remember you can write this with a half exponent if you want. I'm going to do that just to remind you of that. Square roots can be written with half exponents. We'll be doing that a lot in the weeks to come, like that. And either way you want to write the answer in this case is fine. So there's that. Let's go ahead and look at 2 more of these. All right, here we have a rational function. Again, we're going to find h prime of x, and that's going to be the limit as h, 2 h's. I'm not digging this. Do you guys see why I'm not liking it? I'm going to have h's with h's. I'm just going to confuse the heck out of myself. So let's try something different. Remember what these h's are, right? If you have some function like this, from this point to this point, you have a secant line, right? Like that. And if this is x, we've been saying plus h, but really it's a delta x. It's a change in x. So this horizontal distance here is delta x. This point here is x comma f of x. And this point here is x plus a little bit, known as delta x, change in x, again, comma f of x plus delta x. All this time we've been using h for this guy, right? H. Over here, h. Over there, h. And that's fine, that's the way our book does it. But really it's a change in x. And the reason I'm going to do it here as a change in x is because I don't want to have these 2 h's that mean different things floating around and confusing us. So what we have, and real quick, so we have this horizontal change right there is our delta x in blue, and our, I don't know, purple rise is f of x plus delta x minus f of x, right? That's the height here minus the height there to get that rise over, well, that rise. And now we have rise over run. So we're going to go ahead and do h prime this time. Instead of delta x, instead of h going to 0, we're going to write delta x is going to 0. And I know it's tempting to think of delta and x as 2 separate variables or 2 separate items, whatever, but we're not. We're thinking of it as all one thing. It's change in x. And so we have, let me write that a little neater. So we have delta x approaching 0 here. And we're going to get delta x in the bottom instead of h, right? On top, we're going to have h of x plus a little bit minus h of x. Okay, so if my function were h here, right, it would just look like that. And this would be h of x plus delta x minus h of x. So hopefully that makes sense. It's literally the same thing we're doing. We're just using different variables, right? We're just calling things different names, if you will. And it's kind of good to get used to that. So hopefully that makes sense. But you could, on the other hand, change the name of the function and just do it like we've been doing all the others. So I don't know, probably belabored that point a little too much, but it doesn't matter. So what do we have? We've got the limit as delta x goes to 0. We're going to put, in blue, we're going to put x plus delta x here and x plus delta x there. So we're going to get x plus delta x over x plus delta x minus 3 minus, in green, we're just copying the function, x over x minus 3. all over delta x. Okay, so hopefully that's making some sense what's happening here. Again, just all the delta x's, originally we were doing them with lowercase h's. All right, so continuing on. I'm noticing that I have two fractions on top that are being subtracted. It sure would be nice to subtract them. So I'm going to go ahead and make common denominators. And let's see, let's do it in the next step. The limit as delta x approaches 0. Let's do this. I'm going to take my blue. I'm going to leave it blue for now. In the denominator of blue, I have x plus delta x minus 3. I'm going to put that in parentheses. And then on top, I'm going to put x plus delta x in parentheses. And if you sneak a peek over at green, it sure would be nice if we had an x minus 3 here and an x minus 3 there, right? I'm getting it from there. And then subtracting from that, in green, we already have an x, and we already have, I'm going to put it in back here, an x minus 3. And if we were to grab the x plus delta x minus 3 like that, then we'd have the same denominator in each one of them. And we'll be able to combine the fractions. Okay, there are other ways of doing this. You could multiply back here, you can multiply top and bottom by the LCD of the denominators. I actually like that better. It's a little more efficient, it's a little cleaner. But for now, this is something that usually students understand first, so I'm doing it this way. And later on, we'll have an opportunity to play with other options. So the limit as delta x goes to 0. I'm going to take this numerator here, and I'm just going to combine these over a single denominator. So you could multiply all this together right now. I'm going to wait a moment before doing that and just write this so we're not doing too many steps at once. And here we have x plus delta x minus 3 times x minus 3. And then all of that is being divided by delta x, right? This right here is a big division bar. So we're dividing by delta x. You know that dividing by delta x is the same as multiplying by 1 over delta x. So we can do this like that. All right. I'm not going to multiply out the bottom. And hopefully you're seeing why. The reason we get 0 over 0 with direct substitution is because of this factor right here. So I want to be able to cancel that out. So I don't want to multiply it in with everything else. We do need to multiply this in yellow. And we do need to distribute this in green. So that's what we're going to do right now. I think we get x squared minus 3x, right? I'm multiplying here, multiplying there. And now it gets a little weird because we're going to multiply delta x times x. Okay, do not turn it into delta x squared. Delta x is something different from x. Okay, remember, delta x is its own little variable. So let's go ahead and just first notice that a positive times a positive is a positive. And I'm going to put it in parentheses just so it's really clear like that they're being multiplied. And then finally, we're going to multiply negative 3 times delta x minus, okay? So I think I got all my multiplications there, right? I've got x squared minus 3x, delta x times x, negative 3 times delta x, okay? Now, I need to distribute this guy, and that's going to be a matter of, I got to move this, I don't have space, a matter of making sure that we don't mess up our sign, right? So I've got a negative x squared with the first multiplication, a negative x times delta x, and again, I don't have enough space, and then a positive 3x, and we are multiplying by 1 over delta x. I don't know about you, but I'm sick of having this here, so I'm just going to move it right here in front and get rid of it, like that. So dividing by delta x is the same as multiplying by 1 over delta x, and that's how the delta x is in the denominator. Okay, horrible, ugly mess. but some good things happen. Okay, I'm going to do this with highlighting this time. Light blue right there cancels with that one right there. Yeah? What else cancels? Here, let's do a different color. Purple cancels with purple. And then finally, green cancels with green. And so you'll notice that all you have left that's not colored here is -3 delta x. And the delta x's, just like the h's normally, cancel off. And that's when we know we're in good shape because we can do direct sub without getting 0 over 0. So let's clean that up. The limit as delta x approaches 0, we've got -3 in the numerator. And on the bottom, we have x plus delta x minus 3 times x minus 3. Letting delta x go to 0, we now have -3 over x minus 3 times x minus 3, which of course is -3 over x minus 3 squared. And that is the derivative. H prime of x is equal to -3 over x minus 3, like that. And there it is. And so my main takeaway from this problem is I'm not going to give you a function h of x when I'm asking you to use the limit definition of a derivative because the h's get all confused. I understand if you don't like the delta x stuff, I'm not going to make you use delta x, but it's nice to use because it's more suggestive of what h really is, right? Not this h, but the h we normally use in our limit definition. So let's look at one more. Here, if you notice, what I've been building up the problems, right? So here we did a square root. We start off with something pretty straightforward with the very first one, but here we have a square root, and then here we have a rational function that we're taking a derivative of, and now we have a rational function. Well, we have a fraction involving a square root, so we're kind of combining the last two. So let's go ahead and go back to our definition. R prime of x is equal to the limit as h approaches 0 of, we're going to have an h in the bottom. On top, we're going to have f of x, oh, not f, it's r, isn't it? Pay attention. R of x plus h minus r of x, like that. I'm going to do this, and there it is. So plugging in, limit as h approaches 0, we need to put x plus h in as our input into the green function. And so that's going to give us, actually let's wait on that. That's going to give us what? I said green function, I should have said blue function, right? 2 over the square root of x plus h minus 4. And then on the green part, we have 2 over the square root of x minus 4. All right. There's more than one way of getting there on this one. And we could combine the fractions. Actually, it doesn't matter. This can be done a variety of ways. Let's go ahead and do this. Let's clear the fractions on top. And so I'm going to do this a little bit differently than we did on the previous one. I'm going to take the least common denominator, which in this case is the square root of x plus h minus 4 times the square root of x minus 4. And I'm going to multiply that on top of my fraction like this, but I'm also going to multiply it on the bottom of my fraction like this. Okay, and so we're going to end up distributing here, and then seeing what we get. Okay, again, as usual, this stuff is mostly just a bunch of algebra. Limit as h approaches 0. When we do this first multiplication here, we're going to have a 2, but notice that, I'm just going to highlight these temporarily, this guy is going to cancel with that guy. Right? just that first multiplication with the black arrow, those two are going to cancel. And we're going to be left with 2 root x minus 4, right? This is left over, and that's left over with that first multiplication. Okay, now what? Now we have minus sign. When we multiply this whole thing here, right, we're going to get a 2, but now this guy is canceling with that guy. And so we end up with the 2 times the square root of x plus h minus 4 all over. The denominators up here went away because they both canceled off. And so all we have left on the bottom is the h times the square root of x plus h minus 4 times x minus 4 like that. And really we don't need parentheses because this is just all one big product on the bottom. Okay, so hopefully we did okay with that. I could have written out more steps, but it ends up becoming really cumbersome, so I chose not to. But hopefully that's enough to kind of see what's going on there. All right, now from there, just cleaning this up a little bit. From there, we notice that we have a square root on top that's subtracting from another square root, right? So we're going to go ahead and multiply by the conjugate. So let's pick some other color here. Let's multiply by 2 square root of x minus 4 plus 2 square root of x plus h minus 4 all over the exact same thing. And this thing's getting kind of cumbersome, but once we get through this next multiplication, the numerator will simplify, and then we'll be ready to take, we'll be ready to cancel the h, and we'll be able to be ready to take the limit. So we've got to go do a bunch of multiplication. So here, let's see. If we multiply here, we're going to get a 4, and x minus 4 comes out of the square root. When we go ahead and multiply way out here, we get a positive 4, and then the 2 different square roots are multiplying. And multiplying here, we get a negative 4, and the 2 square roots are multiplying. We add those up, they're gone. Okay, the middle terms go away. We've seen that a bunch of times before when we were doing limits before. And then finally, we're going to multiply these guys, which will give us a negative 4, and all of this comes out of the square root. Of course, we need those parentheses. We've got to be careful. And then the bottom is a big mess, of course. We have x plus h minus 4 under a square root, x minus 4 under a square root, and then we're multiplying this whole thing right here. Can't forget that. I've forgotten that a few times in my past. X plus h minus 4, like that. And so now we have this mess. But there's good news, because we're going to distribute, get 4x, and here we're going to get minus 4x. We're going to distribute to get a negative 16, and here, when we distribute, we're going to get a positive 16. Whoops, I lost my 0 there. So let's take a look at what that turns out to be. We have 4x minus 16 minus 4x minus 4h plus 16 all over this business down here. All right, so now we're going to go ahead and cancel 4x, negative 16, 16. All that's left is a negative 4 on top times an h. So this h in purple and that h in purple can be canceled now that everything else has been subtracted, added away. So now we're left with the limit as h approaches 0 of negative 4 on top over the square root of x plus h minus 4. Square root of x minus 4, 2 times the square root of x minus 4 plus 2 times the square root of x plus h minus 4. Oh my goodness, what a mess. Close those parentheses. But all we're going to do now is plug 0 in here and 0 in there. and then we are going to simplify and we'll be done. So negative 4 over, we have these, let's do this. Let's highlight these in green. When I put a 0 in for that first h in yellow, this stuff in green is going to be the square root of x minus 4 times the square root of x minus 4, and that green part just becomes x minus 4. Okay, if you want to write this more than one step, go for it. It's time to finish up this problem. From there, we have a 2 square root of x minus 4 plus, this goes to 0, so we're going to have another 2 square root of x minus 4. All right, continuing on, we've got negative 4 over x minus 4. I have 2 of these and 2 more, so I'm going to have times 4 square root of x minus 4. And you might be thinking, I'm done, I'm leaving it there. But we can actually take this a little bit further, can't we? We can cancel off the 4s. I'm just trying to decide where I might have room to fit this. We can cancel off the 4s. Let's go over here. We're going to have negative 1 over x minus 4 times, if you remember, a square root is the same as the contents inside to the half power. And so now we can add exponents on these two factors in the bottom, right? This has a 1 here, also known as a 2 over 2. And if we add exponents, we're going to have x minus 4 to the 3 halves. Look at that. And this is actually how I like the result here the best. And we'll see why that is later in a future chapter or a future section. But for now, we'll just leave it there like that. All right, so that last one was a little involved. We had to deal with compound fractions, and we had to deal with multiplying by the conjugate, and then we had to make sure that we didn't lose anything along the way. A lot of this is making sure you don't forget about a term here or multiplying something there. It's a lot of kind of accounting work, making sure that everything is accounted for. So when you go on and do the rest of these on your own, you'll notice that number 1a, this guy is very similar to the first one we did, and then this one's similar to the second one we did, and then next one's going to have a fraction involved, and the last one has a fraction and a square root involved. So go ahead and do those on your own, and be really careful with your algebra. That's kind of the name of the game.